Welcome to the Explainer. You ever wonder how your shopping cart just knows what you put in it? Or how your social media feed is perfectly curated with all your friends? Well, the secret sauce behind almost all of it is a really elegant idea called the Relational Database Model. So let's pull back the curtain and see how it all works. We're going to build our understanding from the ground up, piece by piece. First, we'll look at how this model takes messy data and makes it simple. Then we'll see how we find exactly what we're looking for using special keys. After that, we'll connect all the pieces together. And finally, we'll talk about the rules of the road that keep all our data trustworthy. All right, first up, making data simple. Before the relational model came along, trying to manage data was, well, a nightmare. Imagine a library where all the books are just thrown in a giant pile on the floor. That's kind of what it was like. It was pure chaos. The relational model was the genius idea that finally brought some order. E.F. Codd, the guy who invented this whole thing, came up with a perfect analogy. He said the old way was like driving a stick shift. You had to be an expert, constantly wrestling with the clutch and the gears just to get it to work. But the relational model? He said that's like driving an automatic. You just focus on where you want to go and it handles all the complicated stuff for you. And this right here shows you exactly what he meant. On the left, you've got the engine, all the greasy, complicated technical details of how the data is actually stored on a disk. But on the right, you've got the dashboard. It's the simple, clean, logical view that we, the users, get to see and interact with. It hides all the complexity so we can just get our work done. So what does this simple, logical view actually look like? It's something you already know. A table, just like a spreadsheet, with neat rows and columns. Instead of some tangled, crazy web of data, everything is organized into these simple, intuitive tables. And this incredibly simple idea is the foundation for, well, everything else. Okay, so we've got our data in these nice, neat tables. But now, how do we find anything? That's where keys come into play. Think of them as the secret index that lets you find any piece of information instantly. I mean, think about it. You go to look for your friend Sarah Chen online. How many Sarah Chens do you think there are in the world? A lot. How does the system know which one is your friend and not some random person on the other side of the planet? This is the exact problem that keys were designed to solve. So check out this simple student table. We could easily have two students named Maria Garcia, right? That's totally possible. But what we can't have are two students with the same student number. That number, the STU_num, is the unique key that guarantees we can pinpoint the exact student we're looking for every single time with zero mistakes. And this leads us to a really core concept called determination. It sounds kind of fancy, but it's super simple. It just means if you know one thing, you automatically know another. If I give you a student number, that number determines the student's last name. There's no ambiguity. One points directly to the other. This special, unique identifier is so important it gets its own name, the primary key. It's basically the social security number for every single row in your table. And it has two strict rules. It absolutely has to be unique, and it can never, ever be empty. This is what gives every piece of data its own identity. So if primary keys give each row a unique ID, how do we connect to different tables? Say, a table of students and a table of classes. Well, that's where the foreign key comes in. You take the primary key from one table and you place it in another table to create a link. It's the bridge, the glue that lets us build relationships between our data. All right, let's get to the fun part. We've got our tables, we've got our keys. Now let's see how we use them to connect everything. This right here is where the real magic of relational databases happens. Here we go. We've got a table of customers. Simple enough. Each one has a unique customer code. That's our primary key. But look closely. See that agent code column? That's not a primary key here. That's a little clue, a pointer, that's telling us this customer is related to something in another table. And here's where that pointer takes us, to the agent table. Each sales agent has their own unique agent code, which is the primary key for this table. So now we've got two totally separate tables, one for customers, one for agents, but they're linked by that shared agent code. So the big question is, how do we actually use that link? How do we get a nice, clean list that shows us which agent works with which customer? The answer is a super powerful operation called a join. This is what lets an e-commerce site show you your order history. It joins your customer info from one table with your product orders from another. It's the star of the show. So how does a join actually work? It's kind of like a detective solving a case. First, behind the scenes, the database mashes everything together. It makes a temporary list of every possible customer-agent combination. Then it does the smart part. It goes through that massive list and only keeps the pairs where the agent codes actually match. And finally, it cleans it all up, gets rid of the extra columns, and presents you with one perfect, unified table that answers your question. Okay, we've built our database, we've connected our tables, we're getting meaningful answers. Now for the last and maybe most important piece of the puzzle. We have to make sure the data stays reliable. We need some rules of the road to keep our data honest. And really, it all comes down to these two golden rules. First, entity integrity. This just means what we said before. Every single row must have a unique, non-empty primary key. Simple. Second, referential integrity. This rule protects our links. It says that a foreign key has to point to a primary key that actually exists. You can't have a customer assigned to an agent who's been deleted from the system. This rule prevents broken links and ghost data. And why does this matter so much? What happens when we break these rules and data isn't honest? Well, you get chaos. You get bank transactions that get recorded twice. You get an online order that gets shipped to the wrong address, or worse, just gets lost forever. Without these simple integrity rules, the digital world we rely on would pretty quickly fall apart. And there you have it, the relational database model, broken down into its simple, powerful building blocks. These concepts are truly the unsung heroes of our digital lives, working constantly behind the scenes. So next time you use an app or a website, you'll know a little bit more about the elegant logic that makes it all possible. Thanks for joining us on The Explainer.